Alright, so we can look at the bit ordering of cells by using the simulator. So JavaSim is the main simulator. It's really a graphical simulator. It'll bring up a graphical window that you can interact with, but it also has a command line interface built in, and that's the one we're going to use in this case. So we can use the D command to dump the contents of a cell's truth table. Here's the truth table for cell 00, and as you would expect, it's all zeros. That's the initial condition. And ticking the clock with the T command has no effect on the truth table because the cell is in D mode. But if I set the cell to C mode by putting one of its control inputs to 1, and then I also set the D input on that same side to be 1, now if I tick the truth table once, I see a single 1 loaded in to the truth table, this 1 down here. If I tick again and I dump, I see that the second bit of the truth table has been written. Now maybe I'll set the D input to 0, tick once more, set the D input to 1 and tick one more time, and now we see that we've written in a pattern of 1, 1, 0, 1. If I tick another 60 times, that writes another 60 bits of the truth table with 1s, which should be the rest of these 4 rows. So now if I look at cell 00, we see we've written a bunch of 1s except for this 1 bit that we zeroed out. If we do one more tick, we'll begin writing the C columns of the truth table. So the control west output for an all 1 input will get set, which we can see here. And now if we tick another 63 times, the entire cell will be filled up with 1s except for that 1 bit. The next cell we're going to write is this bit here, the data west output for the last row. And so if I were to set the data west input to 0 and then tick once, we see that we've now zeroed out this bit. We can look at this one and we can tick once more and look at the truth table. We've written 2 zeros, and now we're about to write this bit. We could set the data west input to 1 and tick, and now we've written a 1, and we could look at this one and invert that to set a 0 to the data west input, tick once, and now we've inverted the last 4 bits of this last row from 1, 1, 0, 1 to 0, 0, 1, 0. So the 2 points here are, 1, the bit ordering begins with this last data west output, moves in kind of this row major reverse fashion through all the D outputs, and then comes down here to the last row of C outputs and moves in the row major way back up to finally control north, and the first row being the last bit. The other thing is to just observe that the bits that we have to load in to put a new value in can be specified after we've already read the value coming out of the truth table. So that's how we're able to read, modify, and write in a single clock cycle.